All right, we got that annoying cat who is trying to knock ornaments off of the Christmas tree. So what we want to know here is, will that glass Christmas ball that's falling from a height of 15 centimeters, because that cat is annoying and batting it, is that ball going to break when it hits the ground? Well, we're given some information to compare to. The Christmas ball will break if it hits the ground moving 2.0 meters per second or faster. That's a 2.0. I got a little sloppy there. Okay, so what do we got to do? What do we have to do? We have to think about our height and find the final velocity in order to see if it's going to break. What's our final velocity? That should actually say V final. Okay, so givens. Okay, here we go. We know that the ball is 15 centimeters off the ground. We know because it's a falling object, we're dealing with gravity and initial velocity of 0, and our unknown is final velocity. But wait a minute, folks. Don't think it's that easy, because we need to use our common sense here and think about this. When we plug these numbers in, we have to be working in consistent units. Meters, centimeters. Can't use that. So we have to have an extra step in here where we convert centimeters to meters. Okay. If you do your conversion in the solution section and not show it in the equation section, don't take points off when you self-assess. Just make a little note that you should probably note that you need to do a conversion. But some of you were like really harsh on yourselves, which I appreciate your honesty. Some of you were grading yourselves pretty hard and, you know, saying, ooh, I'm taking off points for doing it in the wrong spot. I would say that I'm more lenient than that. And if you did the work, but it was in the wrong spot, I would usually just circle it and draw an arrow to show you where to put it, in which box. So you can do that as well and just make a note in your assessment notes. So the first part of our equation is to convert using the conversion factor 1 meter equals 100 centimeters. And the second part is to solve for final velocity, which we just use this equation and we turn it into the square root of this, 2gd, because initial velocity is 0, so we just take it out, and we square root to get both sides the same. Initially, I wrote no need to manipulate, but I forgot we really have to get rid of that square there, so we really should turn it into this problem. Okay, where's our solution? Well, we convert 15 centimeters into meters, which is really doing the decimal shuffle 2 to the left. If you use King Henry died by drinking chocolate milk, kilo, hecta, deca, base unit, deci, centi, milli. You start at centi. You're going left 2 jumps to meters, which means you do the decimal slide 2 to the left. But to show it mathematically, we take the number we're starting with and unit. The unit we're throwing out, getting rid of, goes in the garbage underneath the kitchen counter here. The unit we're turning into goes up on top of the counter. So centimeters will cancel out, leaving us with meters. Since the conversion is 1 meter is 100 centimeters, in this problem, you're actually dividing by 100, okay? Which gives us 2 to the left, 0.15. So we take that now, we can plug it in here so that our units are consistent throughout. So we end up with VF squared is 2GD, okay? We're going to multiply out 2 times 10 times 0.15 meters. We get 3. I made a mistake there. I thought, oops, I got the answer. And I was, wait a minute, I didn't do the square root part. So that could be an easy mistake people can make. So then after I put the box around it, I realized I shouldn't have put the box yet. So I now take the square root and I get the final velocity of the Christmas ball falling from 15 centimeters off the ground is 1.7 meters per second squared. Thank goodness, that was one of my favorite Christmas ornaments. It will not break because it was not moving 2 meters per second or faster. So one of those special ornaments, not going to break. The cat gets to stay.